Student, welcome in today's lecture. In this lecture, we will continue the yesterday's lecture. So, what we saw yesterday's lecture, we conclude there. The as per the scientist Griffith, the Griffith was conclude there in his result. What they conclude? They conclude there it was the transforming principle. So on which basis he conclude it was the transforming principle on the basis of his fourth step. Okay. So what was the fourth Griffith step? The fourth Griffith step was the heat killed smooth strain. Okay. It is mixed with the rough strain. Okay, it is mixed with the rough strain. So this is the heat killed smooth strain. Okay, yesterday we have seen in that lecture. Okay, or in the previous lecture we saw there. So this is the heat killed smooth strain. This is the rough strain, and such a mixture when it is injected in the body of mice. Okay, what type of these symptoms shown by that mice? That mice immediately are showing the symptoms of the pneumonia disease, and at its severity, the mice died. Okay, mice died at the severity of the pneumonia disease. So, on the basis of his fourth step, okay, on the basis of his fourth step, the scientist Fred Griffith, they conclude there the something it is transferred from the heat kill smooth strain toward the rough strain, and because of that, the rough strain it is converted into smooth strain. So because of that, that mice died. Okay, because he isolate the blood sample. Okay, blood sample from the dead body of mice, and from the blood sample he obtained the what type of the bacteria. He obtained the all the bacteria, they are of the smooth strain type. Okay, though this smooth strain type bacteria, they are not injected in the body of mice, then and then also he obtained in the uh, died mice the smooth strain. So why such things happen? Uh, it is happen because of the something it is transferred from heat killed smooth strain toward the rough strain, and that rough strain they change its property in the sense they synthesize the capsule around itself, and that means the rough strain it is converted into a such type of the smooth strain. And you know that the smooth strain it is virulent, it is having its capacity to cause the disease, and that mice they immediately died. Okay, so this was the fourth step of the Griffith's experiment. Then later on, the group of scientists Avery, MacLeod, and McCarty. Okay, Avery, MacLeod, and McCarty. Okay, Avery, MacLeod, and McCarty. They perform again a one experiment. Okay, in 1944, they perform a one experiment to prove the what is actually transferred from the heat kill smooth strain toward the rough strain. So, considering the conclusion made by the scientist Fred Griffith, this group of three scientists, Avery, MacLeod, and McCarty, they perform a one experiment. And remember, these scientists they perform a one experiment, and that experiment he performed in the test tube. Okay, in the test tube. So the experiment, what was the experiment performed by the scientists, this group of three scientists, that experiment was the test tube, okay, assay. That experiment was the test tube assay. What they had done there, they isolate the all the things from the heat killed smooth strain. So from this heat killed smooth strain, okay, so this is the heat killed, okay, heat killed smooth strain. And from this heat killed smooth strain, they isolate all the things because that type of the conclusion made by the scientist Fred Griffith. What was that conclusion? The something it is transferred from heat killed smooth strain toward the rough strain, and because of that the rough strain changes property. So with respect to that type of the conclusion, this group of three scientists, they isolate all the things from the heat killed smooth strain. So what they isolate from this heat killed smooth strain, they isolate the RNA, then they isolate the protein, okay, protein, and along with that they isolate the DNA from this heat killed smooth strain. They mix these things with the rough strain, and they observed there in presence of which content that this rough strain changes property. Okay, rough strain changes property. So for that he has taken the test tube. Okay, so suppose this is the first test tube. Okay, this is the first test tube, and he prepared the nutrient medium which is suitable for this rough strain. So this is the nutrient medium. So okay, this is the nutrient medium. Okay, nutrient medium, and inside this nutrient medium, what they put there? They put the rough strain. Okay, this is the rough strain, and this is the, no doubt, this is the first test tube. And in this first test tube, what they add there? They add the RNA. Okay, RNA inside the first test tube. Then what they observed? They observed in the presence of RNA, the rough strain, they remains rough strain. Okay, they remains rough strain. So they never change into smooth strain. Then they try with the next isolated material, that is a protein. So in the second test tube, okay, in the second test tube, they took this protein. Okay, so protein in the nutrient medium, whatever the protein they isolate from this heat killed smooth strain. Okay, protein, and in the presence of this protein, this rough strain, they never change its property. The rough strain, they remains rough. Okay, rough strain remains rough. So the protein and the RNA, it is not a transformed material. Okay, it is not a transforming principle. Okay, it is not a transforming principle. Okay, then he took the next test tube, that is the third test tube. Okay, third test tube. So in this third test tube, as usual, he take the nutrient medium which is suitable for this rough strain. Okay, rough strain. So this is the rough strain. As usual, this is the rough strain. Okay, rough strain. Then inside this test tube, what they add? They added there the DNA. Okay, DNA in the test tube. That means the DNA from the heat killed smooth strain. So in the presence of DNA, okay, in the presence of DNA, this rough strain, they immediately changes property. Means they synthesize the capsule around itself. That capsule, you know that we have mentioned in the previous lecture, that capsule, it is made up of the polypeptide and polysaccharide units. Okay, so this rough strain, they synthesize the capsule around itself. Okay, capsule around itself, in the sense this rough strain, it is changed into this smooth strain. Okay, and you know that this smooth strain, it is having capacity to cause the disease. So because of this, these mice, they immediately showing the symptoms of pneumonia disease, and at its severity, the mice died. And when the scientist Fred Griffith, they isolate the blood from the dead body of mice, and from the blood sample, they obtain there all the bacteria, they are of the smooth strain type, though they are not injected. Okay, though they are not injected, in the sense from the heat killed smooth strain, what is transferred? the DNA it is transferred toward the rub strain, and because of that, this rub strain they synthesize the capsule around itself, and the rub strain it is converted into the smooth strain, and because of this, the mice died. So, on the basis of this, the scientists Avery, MacLeod, and McCarty they conclude there what is the transforming principle. The transforming principle is DNA. Okay, transforming principle is DNA, because in the presence of DNA, the rough strain it is converted into smooth strain. But with respect to the result obtained by the group of three scientists, the other scientists they were not convinced. Then that the Avery, MacLeod, and McCarty, they have to give the proof of this DNA. That means the DNA it acts as a genetic material. Then for that, this group of three scientists they use the three enzymes. They use the three enzymes. See what type of the enzymes they use for proving the exact DNA. It is the transforming principle. So for that, he found the three different types of the enzymes. That is the protein digesting enzyme. It is called as the protease enzyme. Protease enzyme. Then the RNA digesting enzyme, it is the RNase enzyme. Okay, RNase enzyme. Then the DNA digestive enzyme, that is the DNase enzyme. Okay, DNase enzyme. So these three enzymes they used. Okay, these three enzymes they used. What they done there? They take the rub strain. Okay, they take the rub strain here. Okay, rub strain, and then the rub strain. After that, they use here. They remember they use the mixture of the heat killed smooth strain. Okay, heat killed smooth strain. See, and they use these enzymes. Okay, these enzymes. Then in the presence of protease enzyme, first they saw there when they add the protease enzyme. Okay, protease enzyme. Then what they obtain? They obtain there is no change. Okay, there is no change. That means this scientist they obtain or they use the three different types of the enzymes. That is a protease enzyme, RNase enzyme, and the DNase enzyme. Then in the presence of these enzymes, they observed are the rough strain, they shows their the changes among themselves or not. Okay, so for that, what they had done there, they had taken the rough strain plus heat killed smooth strain, and in this mixture when they add the protease enzyme. Okay, when they add the protease enzyme, then protease enzyme, what they do there in this mixture, they digest the protein. Okay, they digest the protein, and when the protein get digested, no doubt there is no change over the transformation. In the sense, the rough strain, it is converted. Okay, it is converted into this स्मूथ स्ट्रेन. म्हणजे ज्यावेळेस त्याने प्रोटीएज एन्झाईम वापरलं त्यावेळेस त्या प्रोटीएज एन्झाईमने काय केलं, हीट किल्ड स्मूथ स्ट्रेनमधलं प्रोटीन डायजेस्ट केलं. आणि तरी देखील हा जो रब स्ट्रेन आहे तो रब स्ट्रेन हा कसा कन्वर्ट झाला, रब स्ट्रेन इट इज कन्वर्टेड इनटू स्मूथ स्ट्रेन. म्हणजे प्रोटीन इट इज नॉट ए ट्रान्सफॉर्मिंग प्रिन्सिपल. What it indicate? The protein is not a transforming principle. Then in the next time they use the RNase enzyme. Then the next time he used the RNase enzyme instead of protease enzyme. RNase. Okay, RNase enzyme. RNase enzyme. Then RNA enzyme इथे काय करेल, या हीट किल्ड स्मूथ स्ट्रेन मधला फक्त RNA डायजेस्ट करेल, बरोबर आहे. पण RNA डायजेस्ट केल्यानंतर ही असं लक्षात आलं की इथे रफ स्ट्रेन इट इज कन्वर्टेड इनटू स्मूथ स्ट्रेन. In the sense, what it indicate the RNA it is not a transforming principle. Okay, RNA is not a transforming principle. Then third time he used the DNase enzyme. Then see what happened. Okay, third time he used the DNase. ओके, DNase एन्झाईम म्हणजे DNA डायजेस्ट करणारं एन्झाईम. मग ह्या DNase एन्झाईमने काय केलं, याच्यामधला DNA डायजेस्ट केला. आणि ज्यावेळेस DNA डायजेस्ट केला त्यावेळेस मात्र रब स्ट्रेनने कॅप्सूल सिंथसाइज केलं नाही. रब स्ट्रेन इट बिकम रब स्ट्रेन. ओके, इट बिकम रब स्ट्रेन. याच्यावरून काय लक्षात येतं की DNA इट एक्ट्स एज अ ट्रान्सफॉर्मिंग प्रिन्सिपल. Okay, DNA it acts as a transforming principle. So in this test tube what we have observed, in the presence of the DNA in the nutrient medium, the rough strain it is converted into smooth strain, and with the help of the DNA digestive enzyme, DNase enzyme, again the Avery, MacLeod and McCarty, they proved that the DNA it acts as a transforming principle, in the sense the DNA it is transferred from heat killed smooth strain toward the rough strain, and because of that the rough strain they change its property, and the rough strain it is converted into smooth strain, and due to presence of the smooth strain in the body of the injected mice, that mice they immediately or they start showing the symptoms of pneumonia disease, and at its severity the mice died. Okay, so on the basis of this group of 3 scientists they conclude there the transforming principle is not a protein, it is not a RNA, it is not a other substance, whatever the substance isolated from the heat killed smooth strain, only the DNA it acts as a transforming principle. So remember student, the transformation phenomenon it was discovered by this group of 3 scientists, Avery, MacLeod and McCarty. So what is that transformation phenomenon? Okay, so always remember the transformation phenomenon it was discovered by the scientists Avery, MacLeod and McCarty. It was not discovered by the scientist Fred Griffith in 1928. Only the scientist Fred Griffith conclude there it is the transforming principle, but they don't know about what is actually transferred from the heat killed smooth strain towards the rough strain. So what is that transformation phenomenon? The transformation phenomenon means it is the transfer of the genetic material from one bacterium to the another bacterium through nutrient medium. It is called as the transformation. मराठीमध्ये आपण असं म्हणतो की ट्रान्सफॉर्मेशन म्हणजे की न्यूट्रिएंट मीडियममध्ये एका बॅक्टेरियामधून दुसऱ्या बॅक्टेरियामध्ये जेनेटिक मटेरियल ज्यावेळेस स्वतःहून ट्रान्सफर होतं त्यावेळेस आपण त्याला ट्रान्सफॉर्मेशन असं म्हणतो. सो ऑलवेज रिमेंबर द ट्रान्सफॉर्मेशन मीन्स इट इज द ट्रान्सफर ऑफ द जेनेटिक मटेरियल फ्रॉम the one bacterium to another bacterium through the nutrient medium. It is called as the transformation. So student, always remember this is the transformation, or what is meant by the transformation. With this the another scientists they were not convinced about the DNA it acts as a genetic material, or with respect to this the transformation phenomenon which was discovered by this scientists Avery, MacLeod and McCarty. Then again the another scientists, that is the scientists Alfred Hershey and Martha Chase, they again proved that the DNA, it acts as a genetic material in 1952. So what was the experiment performed by the scientists Alfred Hershey and Martha Chase with respect to this, the transformation, or with respect to this, the transfer of the genetic material. So let's say the experiment performed by the scientists Alfred Hershey and Martha Chase. So student, scientists Alfred Hershey and Martha Chase, they again proved there the transforming principle is DNA, not a protein, not a RNA. So for that, he had performed the one experiment. And what was the purpose of his experiment? The purpose was the same. That means he want to prove the transforming principle is DNA. Okay. So for that, what they use? They use the isotopes of phosphorus P32 and the isotope of sulfur S35. You know that these two isotopes, this phosphorus, it is the constituent of DNA, and the sulfur, it acts as a constituent of the protein. The microorganism they use, that is, they use the bacteriophage. Bacteriophage means it is the virus that infect the bacterium. It is called as a bacteriophage. So, and the another for the infection, they use the host cell, that is the E. coli type of the bacterium. So this bacteriophage, they infect to the E. coli type of the bacterium. Okay. Then how they perform their experiment? They prepare the nutrient medium. Okay, they prepare the nutrient medium. Suppose this is the container, and in this container they prepare the nutrient medium. Nutrient medium. This nutrient medium, it is suitable for the bacteriophage. It is suitable for the bacteriophage. But what is the characteristic feature of this nutrient medium? That nutrient medium, they contain the both the type of isotope, means P32, which acts as a one of the constituent of the DNA, and the another they add in this, that is the isotope of sulfur, that is S35. Okay. So in the nutrient medium, they had added the two types of the ingredients, that means heavy elements, phosphorus and the sulfur, and in these they grew the bacteriophages. Okay, phages inside this nutrient medium. Then after few generation, he obtained the two types of the bacteriophages. That means they phase with the radio-labeled DNA, because the phosphate they have to incorporate in the phase DNA, and then the another phages they obtain, that is the phages with the radio-labeled protein code, because the heavy sulfur, it get incorporate in the protein coat of the bacteriophage. Okay. So two types of the phages or phages. Student, always remember, you can pronounce phase or phase. Both one it is correct. Okay. So the two types of the phages they obtain there, the phase with or phase with, they say the radio labeled DNA. Okay. So the DNA, they are having the heavy phosphorus. Okay. And another phase, it is a radio labeled protein coat. So this is the protein coat of this bacterium, bacteriophage. So the two types of the phages they obtain inside that nutrient medium. Then what they had done there, they took the infection of these two phages separately on these E. coli type of bacteria. On this E. coli type of bacteria. So this is also a E. coli type of bacteria. So they took the infection of a two different type of the phages. over the E. coli type of bacteria. So the first step, it is the infection of these two radio-labeled bacteriophages with the or on the E. coli type of bacteria. So here this phase, it is the bacteriophage with radio-labeled DNA. They infect over the E. coli type of bacteria, and on this side, this is the bacteriophage with the radio-labeled protein coat. They shows their infection over the E. coli type of bacteria. So this is the first step. Then the second step, the blending. So what is that blending? This bacteriophage, they infect over the bacterium. Then what they do there, they insert this its genomic material inside this bacterium. They insert this genomic material inside this bacterium, in the sense this DNA of this bacteriophage, they get enter inside the bacterial cell. DNA of this bacteriophage, they get enter inside the bacterial cell, and they get incorporate inside the bacterial cell DNA. Inside the bacterial cell DNA. You are aware with that the bacteria, they are having this single circular double stranded DNA molecule. So the phase DNA, it get incorporate inside the bacterial cell DNA. Okay, bacterial cell DNA. So such a type of the incorporation of the phase DNA inside the bacterial cell DNA, it is called as a blending. Blending means it is the mixing. In literature, what we call to that, it is a mixing of the both the type of DNA segments. Okay, then it is followed by the third step. What happened? This after the incorporation of the phase DNA inside the bacterial cell DNA, what happened? This protein coat, it become empty, and such a empty protein coat, it is called as a ghost. Okay, it is called as a ghost, or it is also called as donut. Okay, it is also called as a donut. So you have to remember. Then where it is done, all this experiment, it is done inside the test tube. Okay, inside the test tube. Then the third step, it is the centrifugation. So all these experiment, where it is takes place, it is takes place inside this test tube. Okay, inside this test tube in liquid form. Always remember, it is not done on the table. Because both these things, means bacteriophages and the bacteria, they are microscopic, they are ultra microscopic. So it is unable to visible with the help of our naked eye. So all this experiment, it is performed in the test tube. So after the blending, this ghost or donut of the bacteriophage, म्हणजे त्या व्हायरसचं बाहेरचं आवरण, की ज्याला आपण घोस्ट किंवा डोनट म्हणतो, की जे फक्त प्रोटीनने बनलेलं आहे. लक्षात येतं, म्हणून आपण त्याला प्रोटीन कोट असं म्हणतो. इथेही प्रोटीन कोट म्हणतो. आणि हा काय, हा होस्ट बॅक्टेरियम आहे, की ज्याला आपण ई कोली बॅक्टेरियम असं म्हणतो. ई कोली बॅक्टेरियम म्हणजे ह्या टेस्ट ट्यूबमध्ये आता कोण कोण आहे या स्टेजला, की इथे बॅक्टेरियल सेल्स आहेत, आणि त्याच्यानंतर एम्प्टी झालेल्या काय आहेत, बॅक्टेरियोफेजेसचे कोट आहेत, प्रोटीन कोट आहेत. म्हणून थर्ड स्टेप जी केली, त्या थर्ड स्टेपला म्हटलं जातं सेंट्रीफ्युगेशन किंवा सेंट्रीफ्यूज केलं. सेंट्रीफ्यूज म्हणजे काय, आपण या टेस्ट ट्यूबवरती सेंट्रीफ्युगल फोर्स ॲक्ट करतो. म्हणजे सेंट्रीफ्यूज मशीन वापरून आपण सेंट्रीफ्युगल फोर्स ॲक्ट करतो, हे लक्षात घ्या. आणि त्याच्यामुळं याच्यामध्ये ज्याचं वेट जास्त आहे ते या टेस्ट ट्यूबच्या बेसला सेटल होतं, आणि ज्याचं वेट लाईट आहे ते हे सुपरनेटंट म्हणजे टेस्ट ट्यूबच्या वरच्या बाजूला हे तरंगतं. मग लक्षात घ्या, ज्यावेळेस हे मिक्सचर हे सेंट्रीफ्यूज केलं, त्यावेळेस असं लक्षात आलं की ॲट द बेस, what is settle at the base, all the bacterial cells, okay, all these bacterial cells, they are settled at the base of test tube, and over to or toward the upper side of test tube, in that medium, त्याला आपण सुपरनेटंट म्हणतो. काय म्हणतो, सुपरनेटंट. all these protein coats, okay, all these protein coats, they float टुवर्ड द अप्पर साइड ऑफ टेस्ट ट्यूब की ज्याला आपण सुपरनॅटंट म्हणतो, बरोबर, सुपरनॅटंट म्हणतो. सो दिस गोस्ट इट इज सीन इन दी सुपरनॅटंट of that the centrifuge test tube. Okay, so you have to remember this. Then after that this scientists Alfred Hershey and Martha Chase, they check the radioactivity of this test tube. What they obtain? They obtain there the rather different type of the radioactivity in this side. Okay, that means here they use the bacteriophage having radioactive protein coat. Okay, radioactive protein coat. So the radioactivity it is detected in the supernatant. In this side, the radioactivity it is detected in here. The radioactivity is detected because all the protein coat they float over the supernatant, or in the it is reported in the supernatant. But here remember toward this side where the bacteriophage it is used, which is having the radio-labeled DNA, there the radioactivity it is detected at the base of test tube, because all this E. coli type of bacteria they are settled at the base of test tube, and this ghost, okay, ghost or the empty protein coat of the bacteriophages, they float in this supernatant, but they are not having the radio labeled material. That radio labeled material it is transferred in this bacterial cell. Okay, in this bacterial cell, in the sense, remember student, this radio-labeled phosphorus they get incorporated in the DNA of the bacteriophage, and such a DNA, radio-labeled DNA, they get entered inside the bacterial cell. But here always remember this bacteriophage they are having the radio-labeled protein coat. That protein coat they never get entered inside the bacterial cell, they remain inside the protein coat. So on these scientists Alfred Hershey and Martha Chase, they conclude there the DNA it acts as genetic material, because the DNA they get entered inside the bacterial cell, and the protein it is not a genetic material, because the protein it is never get entered inside this bacterial cell. They remain in the supernatant, in the sense they remain in the protein coat of the bacteriophage, and it is reported in the supernatant. So this scientists Alfred Hershey and Martha Chase, on the basis of his experiment, they conclude there the transforming principle is DNA, it is not a protein. So student, I think you understand well. In the 20th century, right from 1928 to 1952, okay, 1952, we have the idea about the who is responsible for the transfer of character from one generation to next generation. So as per these experiments, what we understand the DNA it acts as a genetic material. So student, this is the first part of this topic. I think you understand well. So with this student we will stop at this moment.